What if the aliens we've dreamed of aren't light years away, but right here in our cosmic backyard? From the dusty plains of Mars to the hidden oceans of icy moons, humanity has explored worlds that might harbor life beyond Earth. But what if we're closer to finding them than we think? In this journey, we'll visit real planets and moons, places we've touched with rovers and probes, and imagine what their aliens could look like. Get ready to explore the unknown, question our place in the universe, and maybe even meet our neighbors. Buckle up, this adventure will spark your imagination like never before. Mars, the Red Survivor. First stop, Mars, the Red Planet. It's a world of extremes, freezing nights, howling dust storms, and a surface blasted by radiation. But Mars isn't as dead as it looks. Scientists have found evidence of ancient rivers, seasonal methane bursts, and even briny water seeping from its cliffs. Could life cling to this harsh world? Picture this. Deep beneath the surface, in lava tubes shielded from cosmic rays, microbial colonies thrive. These tiny Martians might resemble Earth's extremophiles, bacteria that munch on iron oxide, glowing faintly as they metabolize. But what if they've adapted further? Imagine slug-like creatures, their bodies shimmering with metallic scales to reflect radiation, slithering through damp caves. They could use Mars' faint magnetic echoes to sense their surroundings, a bit like sonar. If we found them, would we call them primitive or marvel at their resilience? Mars might be our first clue that life doesn't need Earth to survive. Here's a thought. If life can thrive in Mars' extremes, what does that say about the universe's potential for life? Could we be the odd ones out, or is life the rule, not the exception? Venus, the cloud dweller's paradise. Next, we're heading to Venus, Earth's scorching twin. Just a stone's throw away in our solar system, Venus is a hellscape of extremes. Its surface sizzles at 470 degrees Celsius, hot enough to melt lead, under a crushing atmosphere 90 times denser than Earth's. Thick clouds of sulfuric acid shroud the planet, trapping heat in a runaway greenhouse effect. Yet, in 2020, scientists detected traces of phosphine, a gas linked to life in Venus's upper clouds, sparking wild speculation. Could anything survive here? Picture life in the temperate cloud layer, 50 kilometers up, where conditions are milder, like a balmy summer day. Tiny microbes, similar to Earth's extremophiles, might float in these acidic droplets, feeding on chemical compounds like sulfur. But let's dream bigger. Imagine jellyfish-like floaters, their translucent bodies pulsing with bioluminescent light, drifting on fierce winds that circle the planet in just 4 days. These aliens could have evolved metallic membranes to resist acid corrosion, navigating with chemical sensors instead of eyes. Here's a twist. What if they form living networks, sharing energy like a floating colony? If we sent a probe to scoop Venus's clouds, would we find mere chemicals or a thriving sky city? What would you say to these cloud dwellers if you met them? Could life on a hellish world like Venus change how we define life itself? Europa, the deep sea enigma. Now we're heading to Europa, a moon of Jupiter locked in ice. Beneath its frozen crust lies an ocean deeper than anything on Earth, kept liquid by the tug of Jupiter's gravity. Plumes of water vapor shoot into space, hinting at a dynamic world below. So, what kind of aliens might call this place home? In Europa's pitch-black depths, life could cluster around hydrothermal vents, just like on Earth's seafloor. Think of microbial mats feeding on chemicals, supporting a web of strange creatures. Picture translucent, eel-like swimmers with glowing tendrils hunting in the dark. Or maybe there's something bigger, floating predators with balloon-like bodies, drifting on currents rich with nutrients. Europa's low gravity might favor lightweight, fragile forms, unlike anything we know. If we cracked the ice and peered inside, would we find a bustling ecosystem or a silent abyss staring back? Here's a wild idea. What if Europa's aliens are more advanced than we think, hiding in the depths? Could they be watching us, wondering if we're friend or foe? Enceladus, the icy geyser moon. Let's visit Enceladus, Saturn's dazzling little moon. It's small but mighty, with geysers blasting water, salt, and organic molecules from its subsurface ocean. This ocean, warmed by tidal forces, could be a cradle for life. What might we find in its icy embrace? Near Enceladus's seafloor vents, we could see microbial films thriving on hydrogen and methane. But let's dream bigger. Imagine needle-thin worms that bore into the ice, their bodies sparkling with crystalline armor to withstand the cold. Or picture floating spheres, colonies of cells that pulse with light, riding the geysers up to the surface. Here's a wild idea. What if these aliens can freeze and thaw with the ocean's cycles, waking up when conditions are right? Enceladus could show us life's tenacity in the most unlikely places. If life can survive here, what does that say about the resilience of life across the cosmos? Titan, the methane metropolis. Next, we dive into the icy realm of Titan, Saturn's largest moon. Titan is a frozen wonderland with a thick nitrogen-methane atmosphere denser than Earth's. Its surface, a chilly -180 degrees C, hosts vast lakes, rivers, and seas, not of water, but liquid methane and ethane. Cassini's 2004-2017 mission revealed organic molecules, the building blocks of life, scattered across Titan's dunes. Could life exist in this alien chemistry? In Titan's methane lakes, we might find microbes using hydrogen instead of oxygen, much like Earth's deep-sea vent bacteria. But picture something bolder, eel-like swimmers with flexible silicone-based bodies, slithering through methane currents. Their crystalline eyes could detect Titan's faint infrared light, guiding them to nutrient-rich vents. Or imagine floating spores, ballooning above the lakes, carried by winds to seed new colonies. A sudden storm churns a lake, revealing a predator, a sleek, finned creature that ambushes smaller swimmers with electric pulses. Could Titan's aliens teach us life doesn't need water? If you landed on Titan, would you swim with these methane dwellers or keep your distance? Here's a thought. If life can thrive in methane, how many other impossible places might be teeming with aliens? Beyond the solar system, Proxima Centauri b. Let's leave our solar system for a moment and travel 4.24 light-years to Proxima Centauri b, an exoplanet orbiting the closest star to our Sun. It's in the habitable zone, where liquid water might exist, but its red dwarf star bathes it in intense radiation. What could survive there? Proxima b might host tough photosynthetic organisms. Think dark, leathery plants that soak up the star's faint light. Or maybe there are burrowing creatures with thick, reflective skins to dodge the flares. If water pools on the surface, we could find amphibious aliens with webbed limbs hopping between safe zones. Locked in a tidal dance with its star, one side of Proxima b might be a scorched desert, the other a frozen waste. But at the twilight edge, life could thrive in eternal dusk. Could this be where we meet our first interstellar neighbors? If aliens live so close, what does that say about the universe's potential for life? Kepler 452b, Earth's distant cousin. Now let's soar 1,400 light-years away to Kepler 452b, a planet dubbed Earth's cousin. Orbiting a sun-like star in its habitable zone, Kepler 452b is 1.6 times Earth's size, with a year lasting 385 days. Discovered in 2015, it might have liquid water, rocky terrain and a thicker atmosphere rich in carbon dioxide. What aliens could thrive here? If Kepler 452b has oceans, we might find photosynthetic algae carpeting its shores, soaking up the star's light. But let's go bigger. Picture amphibious creatures with segmented shells, scuttling between land and sea. Their compound eyes, like dragonflies, could track the star's path, while bioluminescent skin signals mates across twilight plains.
Will they greet us with
A
open
sudden
arms,
predator, a winged
or
beast
open
with
claws?
razor-sharp claws, swoops down, sparking a chase across glowing
Will they be
grasslands.
curious or
Kepler
aggressive?
452b's higher gravity might favor stocky, muscular forms, built to endure. If we visited, would these aliens welcome us as explorers or see us as invaders? What gift would you offer to win their trust? Here's a twist. What if Kepler 452b's aliens have already spotted us through their telescopes? TRAPPIST-1e, the Twilight Symphony. Next destination is TRAPPIST-1e, 40 light-years away in the ultra-cool red dwarf system TRAPPIST-1. Discovered in 2017, this Earth-sized planet sits in the habitable zone, potentially hosting liquid water. Its star is dim, bathing TRAPPIST-1e in reddish light. And tidal locking creates a stark divide, one side eternally lit, the other in perpetual night. Life might flourish in the twilight zone where conditions are just right. Dark, moss-like plants could carpet the ground, absorbing infrared light like solar panels. Picture six-legged crawlers, their armored bodies reflecting the star's glow, grazing on these mats. They might navigate using heat-sensitive antennae, dodging predators that lurk in the shadows, sleek, panther-like beasts with infrared vision. Here's a surprise. What if these aliens communicate with rhythmic vibrations, a symphony pulsing through the ground? If we landed in their twilight haven, would we join their song or disrupt their harmony? Could their music hold the key to understanding life in eternal dusk? TOI 700d, the volcanic paradise. Finally, let's venture to TOI 700d, 101 light-years away, discovered in 2020 by NASA's TESS mission. This Earth-sized exoplanet orbits a stable red dwarf in its habitable zone, with a surface that might support liquid water. TOI 700d could have a thin atmosphere, shielding it from stellar flares, and vast oceans dotted with volcanic islands. What life could evolve here? Photosynthetic microbes might tint the seas purple, thriving on the star's red light. Imagine crab-like aliens with bioluminescent shells, scuttling across beaches to harvest microbial mats. Larger predators, serpentine swimmers with glowing lures, could stalk the shallows, ambushing prey with electric shocks. A volcanic eruption sends ash skyward, scattering the crabs in a frantic escape. TOI 700d's stable star suggests life could evolve for billions of years, perhaps even intelligence. If we met sentient beings here, would they share our curiosity or fear our arrival? Here's a thought: what if they've already sent signals and we just haven't heard them yet? The big questions. What does it all mean? From Mars to TOI 700d, we've imagined aliens shaped by worlds we've glimpsed through science. Each one challenges our idea of life, resilient, strange, and maybe even intelligent. But this isn't just a thought experiment, it's a roadmap to discovery. Every probe we send, every signal we catch, brings us closer to the truth. So, what if we find them? A single microbe would prove life is a cosmic spark, not a fluke. Intelligent aliens could reshape our philosophy, technology, even our dreams. Yet, there's a catch. Contact might endanger these worlds or us. Should we whisper hello or stay silent? If you could meet an alien from TRAPPIST-1e, what would you ask them? Let's debate it in the comments. Here's the big one. If we're not alone, what does that mean for humanity's purpose? Are we explorers or just one note in a grand symphony? Conclusion: the call of the cosmos. This journey leaves us with more questions than answers, but that's the thrill of the cosmos. Are aliens out there waiting to be found? Are we ready to meet them? One thing's certain, the universe is vast and our story is just beginning. Smash that like button if you're hooked, subscribe for more cosmic adventures, and tell me, what do you think aliens look like? If you could send one message to the stars, what would it be? Let's keep exploring the wonders of the universe together. See you next time.